Alright, let us take a look now at the second discrete probability distribution, the binomial distribution. Yeah? The binomial coefficients we've just derived. Just also keep in mind that 0 factorial is 1. Yeah? The binomial distribution, in contrast to Bernoulli, has two parameters, n and p. Yeah? And basically, what is it? It is a sequence of independent Bernoulli trials. Yeah? So Bernoulli trials have parameter p, as we've seen. So the Bernoulli distribution is a special case of the binomial distribution where n equals to 1. You have a single coin flip. Okay, let's take a look at the probability mass function, the PMF, the function that we will find. So for Bernoulli, the PMF will depend on K, N, and P. Yeah. So the chance of success has a probability P, but we have K successes, so that means P to the power of K. Failure is 1 minus P, remember, and we have N minus K situations left. Okay, if K are success, N minus K trials left. But the successes can happen anywhere in the sequence of N trials. Yeah? So, in how many ways can we take K from K elements from a pot of N? Now, this is exactly this one. N choose K. So this we have to multiply with N choose K. Yeah? Because there's N choose K different possibilities to distribute K successes out of N trials. So this is your probability mass function for Bernoulli. And if you're gonna look at how this looks like, yeah, it's a little bit like this. Yeah. So that means if N goes to infinity, N goes to infinity, this will actually converge to a Gaussian distribution. And we will see this in the next video. What is the? Let's take a look at an example. We have 5 coin tosses, 3 heads, 2 tails. P of success is 3. The chance of hitting a head is 3. That means that the chance of hitting a tail is 5 minus 3 is 2. Yeah, and we have 5 tosses. So the coefficient is 5 factorial divided by 3 factorial times 2 factorial, and this is 10. Yeah? So it's quite simple. But before we finish, we're gonna take a look at what the expected value is, as well as what the variance is. Well, we know that for one Bernoulli trial, the expectation was P. The expected value was P. Now we have n Bernoulli trials, so we multiply by n. So it's quite simple. Okay, let us take a look at the variance of x. The variance of x. Yeah, in the Bernoulli trial we had p times 1 minus p, and here what we just do is we multiply by n. Yeah? So if you put the variance in relation to p, so when p is 0, your variance is 0, but when p is 1, your variance is also 1. Alright, p is 1, your variance is 0 when p is 1. So your curve will look something like this. Okay, so when p is 50%, you have your highest variance. that means it's a fair coin toss. Okay,